Inverses of trigs. How exciting. Oh my gosh. Oh my gosh. Find the values between 0 and 2 pi radians for which sine of theta is equal to root 2 over 2. Wowza. All right. This is bringing together the full unit circle here. Now, we're going between 0 and 2 pi radians. It's always going to be like that because it's just one circle, right? There could be infinite coterminal angles. We're not even worried about that right now. But let's think like we got our 90, 180, 270, and 360. And we're going to list our answers in degrees and radians. So we'll handle that. Now, sine, if you remember, sine is equal to our y-coordinate. So our y-coordinate in this scenario is positive root 2 over 2. We're trying to find the places on the unit circle where that happens. Here's what I like to do. Figure out the quadrants first. So y is positive in quadrant 1 and quadrant 2. So we're only going to look in quadrant 1 and 2. Now, we have to figure out like which reference angle is that. That's where I think the hand trick is nice. We're looking at sine, which is the y-coordinate. That's our fingers to the right. So we need it where there's 2 fingers on the right. That's a 45-degree reference angle. So we have to figure out a 45-degree reference angle in quadrant 2 and in quadrant 1. The nice thing about quadrant 1 is your reference angle is just the angle. So in quadrant 1, it's going to be 45 degrees. That won't be the case in quadrant 2, because remember, if the reference angle is 45 over here, we're looking for this angle. So we would do 180 degrees minus the 45, which means our other angle would be 135 degrees. Great, that's it. We're also going to do it in radians. Now remember, anytime you have that 45-degree reference angle, those are like fourths of pi. So 45 degrees is 1/4, so it'd be pi over 4. So here's 1/4, 90 degrees is 2/4, 135 would be 3/4, so 3 pi over 4. That's an option. Otherwise, you can always do the conversion thing where you're like 45 degrees times pi radians over 180 degrees, and it will simplify to pi over 4. So however you can get there is great. Let's try more. This is all we're doing today. Find the values, again, where tan is equal to 1. Now remember, tangent is y divided by x. Why are you standing on x? And they're saying that this equals 1. If something divided by something equals 1, that means they need to be the same. So we have to keep in the back of our head that y and x are the same. And it divides to positive 1. So that means they're either both positive or they're both negative. So a quadrant where they're both positive would be quadrant 1. A quadrant where they're both negative would be quadrant 3. So these would be our 2 spots where tangent is positive. Now again, the x and y have to be the same. Do you guys remember which reference angle? The x and y are exactly the same. That's your middle finger down. There's 2 fingers on either side of it. So that's a 45-degree reference angle in those quadrants. So if you have a 45-degree reference angle in quadrant 1, we had that on the first one. It's 45 degrees. And 45-degree reference angle in quadrant 3 would be 180 plus the 45, which is 225 degrees. Again, we're going to convert these also into radians, and then we're done. So 45, you see it all the time. It's just pi over 4. 225, let's see how many 45s that is. Here's 1, 2, 3, 4, 5. It's 5 times 45. So that would be 5 pi over 4. Sick! Super fun! Super exciting! Let's keep going on. Oh! Cosine is equal to 1/2. So cosine is our x coordinate, and it's positive. So we're thinking, which quadrants is the x positive? Well, it's positive in quadrant 1 and in quadrant 4. So those are the two quadrants we're messing with. We have to figure out which reference angle are we referring to here. Now, cosine is our x, which are our fingers to the right. And in this one, we have one finger to the right. What angle does that represent? That represents a 30-degree reference angle. So if it's in quadrant 1, that's our angle, 30 degrees. If there's a 30-degree reference angle in quadrant 4, that's 30 degrees off of 360. So our full angle would be 330 degrees. And we're going to convert these into radians. Now remember, radians is always like how much of 180. So 30 goes into 180 how many times? 6 times. So it's 1/6 of 180. So 30 degrees is pi over 6. Now let's think. 30 to 330, that's times 11. So pi over 6 times 11 is 11 pi over 6. What? See if you can kind of scale it like that rather than doing the conversion each time and simplifying it. If you can kind of start shortcutting that a little bit, I think it'll help your mental math game a little bit. Maybe your mental health game too. Hey, we can all use some help. All right, here we go. Sine is negative root 2 over 2. Now here's the thing I know about the root 2's over 2's. I know it's always a 45-degree reference angle. Every single time. There can't be a 30-degree reference angle with root 2 over 2 or a 60. It doesn't matter if it's sine or cosine. It's not possible. So it has to be a 45-degree reference angle. Now if we're thinking about our quadrants, sine, the y, is negative in quadrant 3 and quadrant 4. So we're worried only about these two quadrants. 45-degree reference angle in quadrant 3 would be 180 plus 45, which is 225 degrees. A 45-degree reference angle in quadrant 4 would be 360 minus 45, which is 315. Now again, we're going to convert these into radians. I know that each 45-degree angle is pi over 4. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Or feel free to convert it. 315 times pi radians over 180. We did that already. All right, here we go. The cosine x coordinate is negative 1. If we have our unit circle, the only spot where x is negative 1 is right here. That coordinate would be negative 1, 0. That's a quadrantal angle, no reference angle. They didn't even ask about the reference angle anyway. This is the only point we care about. Now, what is that in degrees? That's 180 degrees. What is that in radians? Remember, 180 degrees is just pi radians. So it would be 180 degrees and pi. Same thing. Shweti. Oh, wow. I think we have 5 more, and then there's some for you to try. And these are pretty important to try. All right, we have the tangent equal to 0. Now, tangent is y divided by x, and they're saying this comes out to 0. Now, if I had 0 in the denominator, that would be undefined. We can't divide by 0. So this 0 means that y would have to equal 0. So we're looking for spots on the unit circle where y equals 0. Now anytime it's 0 in this case, the y equals 0, that's going to happen at one of the quadrantal angles. Now this point here is 1, 0. This point here, 0, 1. Over here is negative 1, 0. Down here is 0, negative 1. Which spots have a spot where y equals 0? Right here and right here. So if we're listing those in degrees, I know over here is 0 degrees. It's also 360 degrees, but I'm going to write it in order here. So this is 0 degrees. Over here is 180 degrees. And then, like I said, back here again is 360. That's equal to the 0, but we're going from 0 to 2 pi radians, so that would include both of those. Converting these into radians, 0 degrees is just 0. You could write 0 pi, but you don't need to. You could just write 0. 180 degrees is pi, and then 360 degrees is 2 pi. That was tough. That was tough. All right, we're back, baby. Sine is our y coordinate, and we have a positive y. That happens in quadrant 1 and quadrant 2. We need to figure out the reference angle that goes with root 3 over 2. If sine is the y, that's our fingers to the right. We need 3 fingers to the right. That's our pointer finger down. And remember, the pointer finger represents a 60-degree reference angle. So if we're thinking in quadrant 1, 60-degree reference angle is just 60 degrees. But in quadrant 2, if we had a 60-degree reference angle, this other angle would be 180 minus 60, which is 120 degrees. There they are in degrees. Now again, going into radians, it's just what fraction of 180? 60 goes into 180 3 times. So we're going to say it's pi over 3. 120 is just 2 of those, right? 60 times 2, so we'll have 2 pi over 3. Not too bad for the smarties. You are also smart. Look at you. All right, and then cosine is positive. Cosine is our x. The 2 quadrants that have a positive x are quadrant 1 and quadrant 4. Cosine is x. That's our fingers to the left. We need 3 fingers to the left. That would be ring finger down, which represents a 30-degree reference angle. "30 degrees in quadrant 1 is 30 degrees. A 30-degree reference angle in quadrant 4 is 360 minus 30, which is 330. And we'll just scale these. 30 is what fraction of 180? It's 1/6 of 180. So this would be pi over 6. 330 is 30 times 11. Pi over 6 times 11, 11 pi over 6. It's too much fun. Oh, wow. Oh, gee whiz. So much fun. All right, we have 2 more together. Tangent equals -1. Now, every time I see tangent, I actually think in my head, y divided by x. So they're saying this comes out to -1, which means y and x have to be the same number, except one positive, one negative. Now, if it's the same number, I know in my head that's the 45-degree reference angle, the root 2 over 2. But if we're thinking quadrants here, quadrant 1 is a positive divided by a positive, so that would come out positive. So quadrant 1 is out. Quadrant 2 is 1 of each. That's what we need, right? Because we need a positive divided by a negative. So we're definitely going to be in quadrant 2. Quadrant 3, they're both negative, and if you have a negative divided by a negative, it's positive, so that won't work. And then quadrant 4 is positive and negative, which is what we need. So we're in quadrant 2, quadrant 4. I know it's a 45-degree reference angle. So in quadrant 2, if I have a 45-degree reference angle, the angle I'm looking for is here. That's 180 minus our reference angle. So that would be 135 degrees. So one of them is going to be 135 degrees. And down here in quadrant 4, I need the full angle except for that last 45 degrees. So you would do 360 minus the 45, which gives you 315 degrees. So again, the 45-degree reference angle, 45 is pi over 4. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And one full rotation would be 8 pi over 4, which simplifies to 2 pi. So we're feeling fresh right there. This is it. Tangent equals root 3. So they're saying y divided by x came out to root 3, and positive. I know that the only two quadrants where tangent is positive is quadrant 1 and quadrant 3, because it'd be a positive divided by a positive or a negative divided by negative. Now, figuring out what reference angle goes with root 3 is tough. It's either, we know 45, it's going to be 1, because they're both root 2, root 2. So I don't know if it's a 30-degree reference angle or a 60-degree reference angle. So let's figure it out. If it was a 30-degree reference angle in quadrant 1, that means our x would be root 3 over 2, our y would be 1/2. If we're doing y divided by x, that would be 1/2 divided by root 3 over 2. So that would be times 2 over root 3. The 2's cancel out, so we get 1 over root 3, which you would then have to rationalize that denominator. It becomes root 3 over 3. So a 30-degree reference angle, the tangent would be root 3 over 3. So it's not that. And we know it's not 45 because the tangent at 45 is just 1 or negative 1. So it has to be the 60-degree reference angle. But let's double check that. 60-degree reference angle, the x is 1/2, the y is root 3 over 2. If we did y root 3 over 2 divided by x times 2 over 1, 2's canceled out, so it just comes out to root 3. So 60 degrees is the reference angle we're dealing with here. In quadrant 1, that's our degree, 60 degrees. In quadrant 3, that would just be 180 plus the 60. 180 plus 60 is 240. We're going to convert these into radians because it's what we do. 60 is what fraction of 180? It's 1/3. So 60 degrees is 1 pi over 3. I know 60 times 4 is 240. Pi over 3 times 4 is 4 pi over 3. Whoo! Now I have some problems for you to try right here. I'm not even going to talk the rest of the video. I'd recommend you actually try them. Pause the video here and then kind of check in with each row of problems that you're going to try. But give them a whirl. All right. Let's see. Sine is y. Y is positive in quadrant 1, quadrant 2. And root 2 over 2 I know is a 45-degree reference angle. So in quadrant 1 that'd be 45 degrees. Quadrant 2 that'd be 135. 45 degrees is pi over 4. 135 is 3 pi over 4. Tangent is positive in quadrant 1, in quadrant 3. If tangent is 1, that has to be at that 45-degree reference angle. So in quadrant 1, that'd be 45 degrees. Quadrant 3, that would be 225. 225 is pi over 4. 225 is 5 pi over 4. Cosine is x. X is negative in quadrant 2 and quadrant 3. X, fingers to the left, we need one finger to the left, that would be a 60-degree reference angle. So in quadrant 2, 180 minus 60 is 120. 180 plus 60 is 240. Now I know that 60 goes into 180 3 times, so it'd be pi over 3. 120 is that times 2, so 2 pi over 3. And then 240 is 2 times that, so that would be 4 pi over 3. I know I said I wouldn't be talking, and here I am. You just can't shut me up. All right. All right, 4, 5, and 6, where tangent is undefined. If tangent is y divided by x, when it comes out undefined, that means that x is 0. That only happens on the quadrantal angles. So over here, you'd be at 1, 0, 0, 1, negative 1, 0, 0, negative 1. X is 0 up here and down here. So that would be at 90 degrees and 270 degrees. How many 90s go into 182? So pi over 2 and 3 pi over 2. Now this says sine could be plus or minus. So anytime sine is root 3 over 2. So that's going to be in all 4 quadrants. So sine is our y. That means 3 fingers to the right. That means a 60-degree reference angle in all 4 quadrants. So in quadrant 1, that would be 60 degrees. Quadrant 2, 180 minus 60 is 120. Quadrant 3, 180 plus 60 is 240. Quadrant 4, 360 minus 60 is 300 degrees. So 60 is pi over 3. 120 is 60 times 2, so 2 pi over 3. 240 is 60 times 4, 4 pi over 3. 300 is 60 times 5, 5 pi over 3. And the last one, well, that's not true. Cosine x is equal to 0. Again, it's going to be one of those quadrantal angles. When x is 0, x is 0 up here and down there. Oh, all right. So it's the same as number 4. 90, 270, pi over 2, and 3 pi over 2. Cool. 2 more to try out. Sine is negative 1. Sine is the y, and y is negative down in quadrant 2, or sorry, that's quadrant 3, and quadrant 4. We need to figure out, is there a reference angle that goes to that? Oh, interesting. I didn't even think of this. Sine is our y coordinate. They're like, where's the y equal to negative 1? This is the only spot where y equals negative 1. So that's the only spot we need to worry about. That's a 270-degree angle, which is 3 pi over 2. And the last one, this is it, don't get scared now. It's tangent, and it's root 3 over 3. Again, that's either going to be the 30-degree reference angle or 60. I think if I remember correctly, the 30-degree reference angle works for this one. So a 30-degree reference angle would be, the x would be root 3 over 2. The y would be 1/2. So if we divide y divided by x times 2, these cancel, so it becomes 1 over root 3, which is root 3 over 3. So cool. So we are looking at a 30-degree reference angle. I know that tangent is positive in quadrant 1, because they're both positive, or quadrant 3, where they're both negative. So 30-degree reference angle in those two quadrants. In quadrant 1, that would make it a 30-degree angle. Quadrant 3 would be 180 plus 30, which is 210. We're going to convert these into radians. 30 goes into 186 times, so pi over 6. And then we'll multiply it by 7 for that other one. 7 pi over 6, because 30 times 7, yeah. 30 times 7 is 210. Pi over 6 times 7 is 7 pi over 6. That was fun. Oh, it was a really good time.